Before we can learn about how to draw vector graphics in Illustrator, we have to first understand what a vector graphic is. In reality, many people don't even know what the term vector graphics means. It's kind of thrown around a lot when discussing different types of graphical applications. For the most part, there are two different types of ways to draw graphics on a computer. Illustrator primarily uses something called vector graphics, while a program like Photoshop uses something called pixels, which are also sometimes called rasters or bitmaps. We're going to use this example here of a flower to understand the differences between pixel-based graphics, like Photoshop creates, and vector-based graphics, which is what Illustrator creates. To better visualize these concepts, let's first imagine a blank sheet of graph paper. Basically, a sheet of paper that's a grid of a whole bunch of little squares. You may have heard of the term called resolution before, or in regard to an image, something called DPI, or more specifically, PPI, which stands for pixels per inch. Basically, when you create a file in a program like Photoshop, we define first a resolution. A resolution is basically a grid of squares, or pixels. If I create an image that's exactly 1 inch by 1 inch in size, I determine a resolution, or the number of pixels that appear within that 1 inch. So you may have heard, for example, of something called 300 PPI, or 300 pixels per inch. That means that if I create a Photoshop file that is 1 inch by 1 inch, there are 300 of these little squares inside of that document. Obviously, if you try to cram 300 squares into a small space like 1 inch by 1 inch, those squares become very small. When you have very, very small squares, or small pixels, we refer to that image as being high resolution. However, if I create an image that only has, for example, 10 pixels within that 1 inch by 1 inch space, obviously those pixels are bigger. We refer to images with big pixels as having a low resolution. The way that Photoshop creates images is that each of these pixels have some kind of a color value applied to them. Currently, on the screen right now, all the pixels are colored white. But if I wanted to create some kind of an image, I could start to color in some of these pixels. In fact, if you can imagine this as a sheet of graph paper, and if you had a whole bunch of crayons or magic markers, you could start to color in each of these squares. The rule of the game is that you have to fill in each square with only one color, meaning two colors can't occupy the same square. Likewise, every square must be fully colored in, meaning you cannot have a partially filled in square inside of your document. So if I wanted to draw a flower, what I might do is start to fill in these grids with colors. As you can see in this example, this image is set right now to a low resolution. My eye can actually see the individual pixels themselves because they're big enough for me to see. So the flower itself, while very pretty, has kind of these jaggy edges to it, and I can really see the differences or the shades of color within it. In fact, many times inside of Photoshop, you may see that when you zoom in really close to an image, you start to see these pixels. In fact, walk up really close to a TV screen, and you also start to see these pixels. Of course, if you wanted to create a sharper version or a cleaner version of this flower, you might start off with a higher resolution, meaning the pixels are much smaller, and it would be then difficult to see jagged edges inside of your artwork. However, that would only work at the actual size that you create that artwork. As soon as you start to enlarge your Photoshop document, what happens is that new pixels are not added to your file. The pixels that exist in your file simply get bigger. And at some point, as you start to zoom in closer to your document, you're going to see these jagged edges and these pixels. In contrast, Illustrator looks at this sheet of graph paper in a completely different way. It looks at it from a mathematical perspective and actually looks at the graph paper as coordinates. Using these coordinates, you're able to map these things called anchor points, and we'll talk more about anchor points a little bit later. But basically, Illustrator calculates positions for certain anchor points on this grid and then connects each anchor point with a path. Because these paths connect the anchor points, there's really no jagged edges that exist here because the paths themselves are smooth. More importantly, if I now go ahead and enlarge the size of this image, meaning I make the squares a lot bigger, all I'm doing is adjusting the position of these anchor points, but the paths that connect the anchor points still remain smooth and clean and sharp. These paths can have attributes applied to them. For example, something which we call a fill, and again, we'll talk more about fills a little bit later on. But basically, I can apply these colors to fill up the regions inside of these paths to create the colorful flower that I'm looking for. Of course, these paths and these anchor points are not things that print. They're only there for me to work with inside of Illustrator. The same thing, of course, the graph paper here is not something that I would ever see. I could turn it on to see it inside of Illustrator, but it doesn't show up on a printout. What I would see on a printed sheet of paper is simply the beautiful flower with nice, clean, sharp edges and a smooth appearance. This is the main difference between vector graphics and pixel-based or raster graphics. Once I create something inside of Illustrator, I have the ability to resize or edit that graphic at any time without any loss in quality or detail. As we learn more about using Illustrator, we'll learn how to draw these shapes so that we get beautiful looking graphics for any need.